This is going to be question 2 and 3 on page 156. On 2a, it says denote by x and y the dimensions of a plot of land measured in meters. Use the information about the rope's length to write an identity involving x and y. We refer to this identity as the constraint for x and y. Well, first of all, we have to talk about what perimeter means. Perimeter means when we add up all of the sides on a rectangle in our instance. So if this is x, this one down here is also x, and if this is y, this side is also y by definition of a rectangle. To find the perimeter, we would add them all up. So we would have 2x's plus 2y's. And we know that our rope that we were given is 100 meters, so our total perimeter equals 100, which is where I got the constraint for x and y. On part B, we were supposed to write area in terms of x and y. So area of a rectangle is length times width. So in ours, it would be x times y, which is my area formula right there. Then part B also says write a first in terms of x and y, and then use the constraint for x and y to express a as a function of x only. Call this new expression a of x. What is the domain of a of x? To write it in terms of just a of x, we need to solve our previous equation for y so that we can substitute it in. So in order to solve for y, we need to subtract 2x from both sides. We get 2y is equal to 100 minus 2x, and then we're going to divide everything by 2. And that's how I get the equation y equals 50 minus x. Since now I know what y is, I'm going to take this value and substitute it into my area formula for y. So this is where I get my a sub x is equal to x times, my new y now is 50 minus x. The domain of this is going to be, has to be greater than 0, but it needs to be less than 50. If you graph this on GeoGebra, you can see that it creates a parabola. And our parabola has an absolute max right here. And if we were to click on this point is 25, 625, and our 625 was our max in area, which is the same thing that we got in the first problem. In problem 3a, it says, what does the slope, does the tangent line have at the highest point of the graph of a? What does this information tell you about the derivative of a prime of x? Our slope at the tallest point is 0, and this is because we have a max. So this is going to tell us that we have an absolute max, or at least one max. In part B, it says to compute a prime of x. So the first thing I need to do to compute a prime of x is I actually need to take my formula that I had previously and distribute my x. So this is what I had previously. I had x parentheses negative x plus 50. And if I distribute that, I get a negative x squared plus 50x. There should be a plus sign here. So to find the derivative, I'm going to use the power rule. So I would have a negative 2x plus 50. Now I need to find the value of x sub 0 in the interval of 0, 50 with the property that a prime of x sub 0 equals 0. So I'm going to take my derivative and I'm actually going to set it equal to 0. And I'm going to substitute x sub 0 in for x so that I can find its value. I first have to subtract 50 from both sides. I get negative 2x sub 0 is equal to negative 50, and I'm going to divide everything by a negative 2, which solves for x sub 0, which equals 25. Then it says that we need to graph this. So when I use GeoGebra to graph this, you can see that on the right side of our x sub 0, which again was 25, it is positive. And then on the left side of it, oh, I'm sorry, On the right side of it, it is negative. On the left side, it is positive. This tells us that it's the exact definition of a max value. And that is what we saw when we did problem 2 and problem 1 previously, was that there was a max value of an area of 625 meters squared.